Good morning, everyone. Welcome back to this lecture series. So far we have discussed about these key challenges of metamaterials and further improvement. And here I'll go into this how we are going to solve this using the different structure analysis, and what are the key challenges, and how it is be used basically for an wireless communication.
Next is then objective. Our goal is focused on the outcomes like designing the 3D compact hexagonal metamaterial unit cells, uh, which is using the dual split rings and then metal wire lines. And then our focus is on design to achieve the double negative properties where the permittivity and permeability both are negativity, and which it can able to achieve the high refractive index of around 42 and at 2.45 gigahertz. And and finally to enhance the and impedance matching and reduce the surfaces losses with the high refractive index, high effective medium ratio, that is EMR value. So based on this effective medium ratio only, we can able to identify whether the structure has been achieved the compact. If the AMR value is greater than 4, then the structure has become the compactness. So this is making all this objective, which can be suitable for the ideal for the IoT applications. Existing system. In existing system, 2D materials such as the structures can be of any form, such as like cylindrical, square, hexagonal, rectangle. It can be of any shapes, which has been used for the wide range of microwave and wireless applications. But most of the structures are exhibiting either mu epsilon or epsilon negative or the mu negative. That is ENG material or MNG mu negative material, but most of this 2D structure are in a complex form, that is complex structure, which is make us for used for the miniaturization. But whereas in 2D structures, whereas we get the loss of lot of surfaces losses and this radiative loss, so which it can be overcome by the 3D unit cell metamaterial structures. So like designing the vertical SRR, like vertically placed SRR within wire structures, or else like Greek patterns, which is often used for the enhancing this miniaturization and for the multiband performance. So they become more complex and uh, low negative refractive indexes, and there is also which it suffers from the high surfaces losses. Next is the limitations of an existing system. So to summarize, there is a major issues in the current system, like which it exhibits a low negative refractive index when the and then complex fabricated or complex geometric structure, which is due to the intricate geometry, and also which it suffers from the high surfaces losses, which it degrades which it reduce the performance of the wireless environment, and also like low EMR, that is low effective medium ratio, which it limits for the compactness and efficiency. Uh, um, so this are the major thing which we are focusing on making in proper system, which we are focusing on increasing the high negative refractive index, and then making the complex geometry to be the very simpler thing, and then increasing this effective medium ratio. A proposed system is consists of a design of novel 3D metamaterial unit cell using this dual hexagonal split ring resonator within metallic wires. So this 3D MTM is the unit cell, which it combines the two hexagonal split ring resonator. One is placed on the top of the substrate and another is placed on the bottom of the substrate, and both are connected within wire, and there is an air gap between the top of the substrate and the top of the top hexagonal structure. So this structures operates at 2.45 gigahertz, and which is commonly used for an IoT application. So the result is like it exhibits the double negative behavior properties like negative permittivity and then negative permeability, and it also achieves this negative refractive index and then EMR, that is effective medium ratio, is also high, which it confirms that it is this structure is an compact and an effective medium structure. So this setup is significantly useful for reducing this surfaces losses and improves this improves the impedance matching and then gain matching. So when we used as an super substrate on the any antennas, so it helps us to increase the gain of an antenna.